Hello everyone, Bradley Sward here, and this video today is the 2022 Advent of Code Day 8 solution for the Treetop treehouse problem. I did it in C++ this time around. Wanted to have a little bit of fun switching over to something else other than Python, since it was something that was a little more in my wheelhouse when it came to getting the data into a nice little square array and start working from there, as opposed to like a list of lists and all sorts of crazy stuff. But anyway, so there's a ton of numbers here, and just think of every square as a tree with a specific height, and the number is basically the value is the height of that tree. So the question is, how many trees are fully visible from their own location? If basically saying, like, if I go off like this 5 right here, if I go off to the left, it's not visible that way because the tree is at the same height. So you need every value to its left, to its right, or to its up, and or to its bottom. Every one of them has to be less than that 5. And if I can find one direction for this one point, then I go, yes, this tree is visible from somewhere on the outside of the world here. And so, like in this case, yes, a 1 and a 2. So this one's good. Something like, let me find one that isn't. I suppose this 3 right here. You go up, you go right away, it's bad. To the right, right away, it's bad. To the down, right away, it's bad. And to the left, it's bad too because it's the same value. So this one is not a visible tree. And so you do that for every point or every data point inside of our data set here. And you just go, well, how many trees can go one of the 4, or at least one of the 4 directions? And so that's the thought process here. And I kind of hacked it. Now that I have a working solution, it wouldn't be that hard to kind of reduce this down 4 times the amount of code down to 1 and just set up an array of these values and go. But I have my file, my data set. There it is. There's all my data. And it just takes it and just puts it into a 99 by 99 grid. And I can modify this if I need to, depending on if there was a part 2 or part 3 or whatever it was moving on forward. Oh, and I did have this, but luckily for me, using my magic numbers approach here after I figured it out. So get all the data. It's all going to come in as character data, so I have to subtract off the ASCII 0 to get the actual true integer value out of that thing and store that into my data structure. And then from there on, basically for every square, and you have to make sure you don't go off the bounds and check something that is like invalid, because it is an array structure, so you can't go to the negatives. You can't go into past, in this case, the square value of 99. 99 or greater will go past and at least possibly crash your machine, or crash the program at least. So all this is doing 4 times over with just different values for x's and y's. This one just says, let's try going to the right, and if I ever find a tree that is larger or the same, break out. But if I can get through all of this basically and say, like, oh, I found a tree and basically this way isn't going to work, so I break out immediately. And if I get down here and I can't find that counterexample, then I have to admit that this tree is a good one, and I can increase the score and then use the continue to break out of this loop, but go on to the next loop instead of breaking out of the loop altogether. So that's what you're doing for basically all 4 different directions. This is to the right, this is to the left, and then this would go up, and then this would go down. And if one of those 4 works, I guess I could get rid of this continue and whatnot, but again, it works. And when I run this program as such, you get an answer of 1695, which matches the problem right here for that. So then for part 2, basically it says, instead of just counting how many trees are doing their business, we want to figure out some kind of score from the number of trees that are visible from that location in each of the 4 directions, and basically multiply those 4 values together to achieve this score, and basically which tree has the highest score. And that's what we're going off of there, and you can kind of keep on going here and just kind of see that there. It gives us a lot of data for this kind of stuff. And to fix this one up for part 2, then pull in part 2. So it's kind of the same stuff. I hacked out all the stuff I didn't need to, and this stuff is in here because I was testing the specific data point that they gave us inside of the problem description. So I can get rid of these breakpoint locations now. And so instead of checking scores and just adding them as I need to, now I'm keeping track of 4 different values, an A, a B, a C, and a D. A basically keeps track of all the trees that go to the right before I hit my end position. And then the B is saving everybody that goes to the left. So how many trees until I hit something, or I guess go off into infinity or whatever from the edge of the grid. And then the C value is storing everything that's going up, and the D value is storing everything that's going down. And then at the end of the day, when I get through all of that, and there's no need to break, like to break out and do any other kind of testing, I have my 4 values, I multiply them together, and I just keep maintaining the largest one as I go. And when I run it this way, I get an answer of 287,040, and there is my 287,040. So that solves my problem for day 8 in C++ this time and not in Python. As always, well, I say, like, outside of the obvious that I've already explained, if there are better ways to do this, I'd love to hear it. Those of you who are following or watching some of these videos, I appreciate it. So thanks for sticking it out with me. Have a great day, everybody. I hope day 9 is pretty easy as well. This one was in the medium range for me. Took me a while to figure out what's going on. So anyway, take care, everybody. Have a good one. We'll see you next time.